students, we'll start with revision of Unit 2, that is polygons and 2D transformation. Now what are polygon? Polygon is basically a figure having many sides. It may be represented as a number of line segments connected end to end to form a closed figure. The line segment which forms the boundary of polygon are called as edges or sides of polygon. The end point of sides are called the polygon vertices. Now triangle is the most simple form of polygon, having 3 sides and 3 vertices. The polygon may be of any shape. To form a polygon we need minimum 3 vertices and 3 edges, and that too must form a closed figure. Now you will see different types of polygon. Different types of polygons are convex and concave polygon. Convex polygon is a polygon in which if any if we take any 2 points which are surely inside the polygon, and if we draw a line joining these 2 points, and if all the points on the line lies inside the polygon, then such a polygon is called as convex polygon. Right, you can see in the example AB lies inside, CD lies inside the polygon, so it is convex polygon. Now what is concave polygon? Concave polygon is a polygon in which the if we take any 2 points which are surely inside the polygon, and if we draw a line joining these 2 points, and if all the points of that line are not lying inside the polygon, then such a polygon is called concave polygon. Generally the polygon which are not convex are referred as concave polygon. Like you can see the example. Now line AB, the points A and B are inside the polygon, but the line formed AB, after joining these points, then all the points on the line are not inside the polygon, some part is outside. Same goes with C and D, that is concave. Also there is one point that in convex the angle formed from at the vertices is always less than 180 degree, and for concave it can be greater than 180 degree. So we'll go for the next part, that is polygon representation. Now what is polygon representation? We have different ways of representing the polygon. Now uh, when we are going to use the polygon in our suppose graphic system, first we have to decide how to represent the polygon. So some graphic devices give permissions to directly image polygon shapes. In that cases a polygon acts as a whole unit. Now some graphics device provide, we say, trapezoid primitives. Trapezoid primitives means polygons are imaged or drawn in form of trapezoids. Trapezoids are formed by using 2 scan lines and 2 line segments. Some graphic device may not provide support to polygon at all. In that case we have to break up the polygon into lines and points which can be imaged or drawn to form polygon. So we should store full polygon in our display file and then try to investigate or find the method for imaging or displaying them using lines or points. Now for this we have to store the polygon in display file. So display file contains the information necessary to construct the picture. The information will be in the form of commands such as move or line command. The structure of display file is basically 3 arrays, one for opcode, that is command, and other 2 to store x and y values. So if we place line command in opcode array of display file for representing the edge of polygon, and there may be 2 difficulties. First, we will not get exact idea of how many sides the polygon is having or which set of command we have to group. Second difficulty is what should be the starting point from where we have to start drawing polygon. So to overcome this problem, uh, by we can overcome it by, we can say that, prefacing the commands by new command. This new command will tell us how many sides are there for the polygon, and from that we will come to know number of sides of the polygon is having. We can interpret this new command as starting point code to draw first side also. Then we can see what is uh, we can say entering polygons. How to enter? We can enter a polygon into the display file by using an algorithm. The information required to specify the polygon is the number of sides and the coordinates of vertex point. We can use array to pass the coordinates of all vertices to the polygon entering routine. If we are using absolute coordinate, then algorithm can be used to directly enter the polygon. Test. So methods for testing a pixel is inside a polygon or not. How to understand that the pixel is inside a polygon or not? So we generally use two methods for to judge that inside test. We have two methods, that is even odd method and winding number method. So inside outside test can be done with two forms or two methods, that is even odd method and winding number method. What is even odd method? Even odd method. So one method for doing this, that is even odd. You can refer these, for example drawings, is to construct a line segment between a point in question, that is the point to test whether it inside or outside, and a point which is surely outside the polygon. But how we are going to find out a point which is surely outside the polygon? Because it is very easy to find out that point. For example, pick a point with an x coordinate smaller than the smallest x coordinate of polygon, and y coordinate will be any y value, or for simplicity we will take y value same as y value of point in the question. Now in this case, point A, here we have written what, p1, p2, p3, p4. In this case, suppose we say point p2. Point p2 is 1, which we want to check whether point p2 is inside polygon or not. As we are using array to store vertices of polygon, we can easily come to know the vertex which is having lowest value of x, that is x1. So we have to select a point, that x1, and generally we select same point of y as that point A in order to draw a straight line. But even if you select any y value for outside point, it will not make any difference. Then count how many intersections are occurring with the polygon boundary by this line till the point in question, that is it reaches point P2. If there are an odd number of intersections, then the point in question is inside. If even number of intersections, the point is outside the polygon. This is called as even odd method to determine interior point of a polygon. So suppose for point P1, this is P1, we'll draw a line. It intersects here, one intersection, two intersection. It is even, so the point is outside. P2 intersection, 1, 2, 3, three intersections with the polygon edges, right? It is odd, so point is inside. P3 intersection 1, right? Odd, so point is inside. P4 intersections are 2, it is even, so point is outside, right? So this is even odd test. But this even odd test fails for one case, that is when the intersection point is on the vertex, exactly on the vertex. Now, so if the case is that the intersection point is exactly at the vertex, we have to make some changes and find out. So now next is winding number method. What is winding number method? The alternate method. It is alternate method for defining a polygon interior point. So consider now, we can say, a piece of elastic between a point of question and a point of polygon boundary. Treat that elastic is tied to point of question which we want to find out, and other end of plastic is elastic is suppose sliding across the boundary of the polygon until it has made a complete circle. Then we check how many times the elastic has been wound around the point of question. If it is wound at least once, the point is inside. If not, if no net winding, then point is outside. In simple words, we can say that we begin with our even odd method. We draw a line between point of question and outside point, then consider the edge or sides of the polygon where this line crosses. In even odd method, we just count the number of intersections, right? But in winding method, we give direction. We can say we can give direction number to each boundary line, which is crossed by the line, and then we sum these direction numbers. So direction number indicates the direction in which polygon edges are drawn. The side which starts at the above the draw line and the cross lines and then end below the line. In that case, we assign the side direction number as 1. If the edge of the polygon starts, we say, below the draw line, crosses the line, then ends above the line, we give it -1 to the direction number. The direction number. And then find the sum of these numbers. If the sum is non-zero, then the point is inside. If the sum is 0, then the point is outside. So here, see, for example, this one is given. Now this is the line and the point is above the line, right? So as these points are above the line for this, and in the next one is, this is the line and both are in one side. So for this we'll consider it as 2, and if it is even, then it is out. For here we'll consider it as 1, as both points are on the other side of the line. So it is one intersection. For this we'll consider as one intersection. For here it will consider as two intersections. Even 2 is even, so it is out, and here intersection is 1, considers 1, so it is in, as it is an odd count. What is polygon filling now? Polygon filling. So filling is the process, we can say, of coloring in a fixed area or region. Region may be defined at pixel level or geometric level. Now when the region are defined at pixel level, we are having different algorithms. So polygon filling algorithms are boundary fill algorithm, flood fill, edge fill, fence fill, scan fill. Now in case of geometric level, we have scan fill algorithm. So we'll see pixel level polygon filling, but before going to actual algorithms, we need to see what is 4 connected and 8 connected. What is 4 connected and 8 connected pixel concept. So these are the two techniques. These two techniques actually are the ways in which pixels are considered as connected to each other. Now in 4 connected method, the pixel may have up to 4 neighboring pixels. So let's assume that the current pixel, that is the center one, is x comma y. From this pixel we can find 4 neighboring pixel as right, above, left and below, right? Right, above, left and below. Similarly, 8 connected method, that is B. 8 connected method, the pixels may have up to 8 neighboring pixel. Hence from one pixel location we are finding the neighboring 8 pixels. So we'll see what is boundary fill. Now this is a very simple algorithm. It needs one point which is surely inside the polygon. This point is called as seed point, which is nothing but a point from which we are starting the filling process. This is recursive method actually. The algorithm check to see if the seed pixel has we can say the boundary pixel color or not. If the answer is no, then fill that pixel with color of boundary and make a recursive call to itself using each of its neighboring pixel as a new seed. If the pixel color is we can say that same as boundary color, then return to its color. So this algorithm works for any shaped polygon and fills that polygon with boundary color. But as it uses high number of we can say recursive call, it takes more time and it takes more memory too. Now we will see what is flood fill. The limitation of boundary fill algorithm are actually overcome in flood fill algorithm, like boundary fill algorithm. This algorithm also begins with seed point, which must be surely inside the polygon. Now now instead of checking the boundary color, this algorithm checks whether the pixel is having the polygon original color, that is previous or old color. If yes, then fill the polygon with new color and uses each of the pixel neighboring pixel as a new seed in a recursive call. So if the answer is no, that is the color of the pixel is already changed, then return to its color. Sometimes if want to fill an area that is not defined within a single color boundary, then in that cases flood fill actually helps. And we can say that flood fill and boundary fill algorithms are somewhat similar. Flood fill algorithm is particularly useful when the region or polygon has not uniform color boundaries. The flood fill algorithm, sometimes also called as seed fill algorithm or forest fire fill algorithm, because it spreads from a single point, that is seed point, in all directions. Next we'll see scanline algorithm. Before that, we'll also refer to the other algorithm. Okay, so let's start with scanfill algorithm. uh, we've already seen what is scanfill algorithm. Let me just show it in the notes. Yeah, here we get it. Scanline algorithm. Now in contrast to boundary fill and flood fill algorithm at pixel level, this algorithm is defined at geometric level, that is coordinates, edge, vertices, etc. This algorithm starts with first scan line and proceeds line by line towards the last scan line and checks whether every pixel on that scan line satisfied our inside point test or not. That is, it checks which point on the scan line are inside the polygon. This method actually avoids the need of seed point. Scan line is mainly used and is highly recommended one. Next is 2D transformations part after scan fill algorithm. So we'll see that in next video. So in this we saw what are polygons, how to draw insert, how to enter a polygon, what is the inside outside test, that is how to find a polygon is inside, how to find a point is inside a polygon or not, and also we saw the methods or algorithms for polygon filling. and in next unit, or sorry, in next part of unit 2, we'll see 2D transformations.